What if the Big Bang wasn't the true beginning, but just one moment in an endless cycle? For decades, scientists seriously considered that possibility, a universe that expands, collapses, and then is born again. But now, new observations are rewriting that story in a dramatic way. This video explores whether the Big Bang could ever happen again, how the universe is actually evolving, and why recent data is forcing scientists to abandon one of the most fascinating ideas in cosmology. And the answer isn't just surprising, it completely changes how we see the fate of everything. The idea that the universe might restart itself has always been one of the most compelling concepts in cosmology. Instead of a single beginning, some models propose that the universe goes through endless cycles, expanding outward, slowing down, collapsing inward, and then bouncing back into a new Big Bang. This concept, known as the Big Bounce, offered an elegant solution to one of the biggest mysteries in physics: what happened before the beginning? For years, this idea wasn't just philosophical, it had real scientific support. Early models of the universe assumed that gravity would eventually overcome expansion. Observations showed galaxies were moving apart, but many scientists believed this expansion would gradually slow down over time. If that happened, gravity could pull everything back together into an incredibly dense state, triggering another expansion event. In that scenario, the Big Bang wouldn't be unique. It would simply be one cycle in a repeating cosmic loop. What made this idea so attractive is that it avoided a true beginning. Instead of asking how something came from nothing, the universe would exist eternally, constantly renewing itself. It also aligned with certain theoretical frameworks in quantum gravity, where a collapse might not lead to a singularity, but instead transition smoothly into a new expansion phase. In other words, the universe would recycle itself indefinitely. But here's where things start to shift. The Big Bounce depends entirely on one critical condition. The universe must eventually stop expanding and begin contracting. Without that reversal, the entire cycle breaks. And for a long time, scientists didn't have precise enough data to confirm whether that slowdown would actually happen. As observational technology improved, astronomers began measuring the universe's expansion more accurately than ever before. Instead of relying on assumptions, they started tracking distant galaxies, mapping cosmic radiation, and analyzing large-scale structures across billions of light years. What they found didn't just challenge the idea of a future collapse, it completely overturned it. Because instead of slowing down, the universe is accelerating, and that single discovery changes everything. The turning point came in the late 1990s, when astronomers studying distant supernovae made a shocking discovery. Instead of finding that the universe's expansion was slowing under the pull of gravity, they found the opposite. It was speeding up. This wasn't a small deviation, it was a fundamental shift in how the universe behaves, confirmed by multiple independent observations. This acceleration is now attributed to a mysterious component called dark energy, which appears to make up roughly 70% of the universe. Unlike gravity, which pulls matter together, dark energy drives space itself to expand faster over time. The more the universe expands, the stronger this effect becomes, pushing galaxies farther apart at an increasing rate. This discovery didn't stand alone. It was reinforced by measurements of the cosmic microwave background, the faint afterglow of the early universe, captured in extraordinary detail by missions like Planck. These observations provided a precise snapshot of the universe's structure and composition, allowing scientists to build a consistent model of cosmic evolution. More recently, large-scale surveys like DESI have taken this even further. By mapping the distribution of millions of galaxies and tracking subtle patterns known as baryon acoustic oscillations, researchers have been able to measure the expansion history of the universe with unprecedented precision. The result? All the data points in the same direction. Expansion is not slowing down, it's accelerating, and it has been for billions of years. This has a direct consequence for the Big Bounce. If the universe never slows down, it can never reverse direction. Without a collapse phase, there's no mechanism to compress the universe back into a dense state that would trigger another Big Bang. The entire cycle breaks down at its core assumption. What makes this conclusion so powerful is the level of agreement across different methods. Supernova observations, cosmic background radiation, and galaxy surveys all converge on the same result. This isn't a single experiment, it's a global, multi-decade effort pointing toward one consistent picture. And that's why many scientists now say the Big Bounce is effectively ruled out, at least in its traditional form. But if the universe won't collapse and restart, then what actually happens next? The most likely future of the universe is not a dramatic collapse or a fiery rebirth, but something far quieter and far more unsettling. According to current models, the universe is heading toward what is known as heat death, a state where all usable energy is eventually exhausted. This process unfolds over unimaginable timescales. As expansion continues, galaxies move farther apart until they are no longer visible to each other. Star formation gradually slows as the raw materials needed to create new stars become depleted. Existing stars burn out, leaving behind remnants like white dwarfs, neutron stars, and black holes. Over trillions of years, even these remnants decay or fade. What remains is a universe that is cold, dark, and incredibly sparse. Energy becomes evenly distributed, leaving no gradients to drive processes like motion, light, or life. It's not an explosion or a collapse, it's a gradual fading into equilibrium, where nothing new can happen. Despite how definitive this sounds, scientists are careful about how confident they are. The current model, often referred to as lambda CDM, fits observational data extremely well. However, there are still open questions, such as the exact nature of dark energy and discrepancies in measurements of the universe's expansion rate. These uncertainties leave room for new physics, but so far, no alternative model has successfully replaced the current one. To understand what we're missing, it helps to imagine what a Big Bounce would actually look like. In that scenario, the universe would begin to contract, with galaxies moving closer together instead of drifting apart. Temperatures would rise as matter becomes more densely packed, eventually reaching conditions similar to those at the beginning of the universe. Instead of collapsing into a singularity, quantum effects might trigger a rebound, launching a new phase of expansion. It's a powerful image, a universe that resets itself in a dramatic cycle. But without observational evidence of contraction, it remains a theoretical possibility rather than a realistic future. This leads to an even deeper question. Has something like this happened before? Some theories show that our universe would be one of many cycles, or that previous universes existed before ours. These ideas often emerge from attempts to unify quantum mechanics with gravity, where the concept of a singular beginning may not apply in the same way. However, there is currently no direct evidence for past cycles. Everything we can observe points back to a single, continuous expansion from an initial, hot, dense state. Until new data suggests otherwise, the idea of previous universes remains speculative. And that brings us to the real conclusion, not just about how the universe ends, but about what kind of universe we live in. So can the Big Bang happen again? Based on everything we know today, the answer is no, not in our universe. The data shows a cosmos that expands faster over time, leaving no room for a future collapse or reset. Instead of an endless cycle, we may be living in a universe that happens once and only once. And that changes everything, because it means the story of the universe isn't about repetition. It's about a single, unfolding journey with a quiet ending. So what do you think? Is dark energy the final answer, or the biggest mystery we haven't solved yet? Comment below your theory. I'm genuinely curious. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.